Hey guys, and welcome to our quiz review video. So we're just going to go through some basic stuff for what's going to be on the quiz here. So we're going to talk about ionic compounds, naming and writing them, covalent compounds, naming and writing them, and balancing. I'll give you some tips and tricks that I use for balancing. If you balance slightly different than I do, you have your own system already set up, that's totally fine. You can stick with that as long as it works. I'm just going to show you what I do, and if you like yours, go nuts. But let's hop into naming ionic compounds. So this is if I give you the chemical compound, like one of these, and ask you, what's the name of this thing? So first thing you're going to do is check and see, is it ionic or covalent, right? Calcium is a metal, so we know it's going to be ionic right away. Covalent is always two nonmetals together. So this is a metal and a nonmetal, it's ionic. And to name ionic, I name the first thing, it is calcium. And then I got to check and see if it's a transition metal. So I look at my periodic table and I look to see if it's in that middle chunk. So if this is my very rough periodic table, something like that. If your metal is anywhere in, let's change colors. If your metal is anywhere in this section here, and kind of, if those are your metalloids, that metal line. So anywhere on this part here, then it's a transition metal and you need Roman numerals. Calcium, luckily for me, is somewhere over there. It is not a transition metal, so I don't need Roman numerals, which means I just name the second thing, chlorine. But I always change the ending to IDE instead of INE. So we would call that calcium chloride. Next one down, same rules. I've got sodium. I name the first one. Then I check my periodic table. Sodium's up here. So it is not a transition metal. I do not need Roman numerals, so I just name the next one, nitrogen. But I change the ending to IDE. So instead of nitrogen, I've got nitride, sodium nitride. All right, we're on number 3 here, C3, whatever you want. I got iron. I check my periodic table. Iron is in this block here somewhere. It's a transition metal. I'm going to need Roman numerals, and we're going to figure out what those are in a minute. And then I name the next one. Oxygen becomes oxide. Okay, so what goes in the Roman numerals is very important. You don't put the number of atoms. You do not do that. You put the charge on iron. Charge goes in the brackets. I guess technically they're parentheses, but whatever. Charge goes in the brackets. So how do we figure out the charge? Well, if you remember for your periodic table, I know this is a +1, this is a +2, this over here is a -1, that's a -2, right? So we can tell what certain elements are. We'll know for sure what they would be. Oxygen is one of those. Oxygen, we know, is always a -2. And I've got 3 of them. I've got 3 sets of -2 for a total of -6. So the negative side of this compound, the oxygen side of this compound, has a total of -6 charge on it. And every compound, unless it has a little plus or minus symbol in the corner somewhere, which I don't think we're even looking at this year, not for a while anyways, they're all neutral. So if the oxygen side is -6, my iron side has to total +6. Now, this doesn't necessarily mean that iron is +6 because I have 2 of them. So I have 2 sets of something to give me a total charge of 6. So 2 times what gives me 6? Well, 3. So iron has a charge of 3. So that iron is a 3 charge. There is a slightly faster way to do it, but it doesn't always work. So a hint you can use is, they call it the crossing method. Iron to oxide. If you take your numbers, let's change colors here, and you switch them, it tells you the charges. Iron is a 3, oxygen is a 2. Now, this doesn't always work, and in order to check if it's working or not, you'll check the one you know. If it suddenly says oxygen is supposed to be a 1, then you're in trouble, because you know that oxygen has to be a 2. Then you're going to have to go back and use this charges method to make sure. So you could just start with the charges method if you like, and it would make sure that you never have to worry about getting one mixed up. Let's take a look at the next one here. I got copper. Copper, again, transition metal. So I'm going to need to put the charge in, and it's paired with sulfate. Oh, now we got a polyatomic in here. I got S and O and 4. How do I know what the charge on that thing is? Well, to figure out the charge on that thing, you just use that polyatomic sheet. You'll be allowed to bring that with you to the quiz, to whatever test. You're going to need to have one with you, so don't forget it. You'd look up sulfate, and it turns out this entire thing, SO4 as a chunk, has a total of -2 charge. So if SO4 is a -2, copper has to be a +2. And because I've only got one of them, there's an invisible one there, that means that copper is the only one that can have the charge. It has to have +2. I'm not dividing by anything. So it's a copper 2 sulfate. This is an example of where that crossover method wouldn't work. So if I were to look at sulfate, I'd say I only have one sulfate, and I only have one copper. So the charge on copper should be a +1, right? And then sulfate's a -1. But if you look, we know from the chart, sulfate's a -2, which means this is wrong. And if that's wrong, the other one's wrong. So don't use the cross-up method all the time. Sometimes it won't work for you, but checking your charges will always work. All right, last one, ammonium nitrate. Well, I guess I just gave it away. I look up NH4 in my polyatomic sheet, and it's ammonium. If it's a polyatomic, you will not have to use the brackets because the polyatomics only have a specific charge. So I don't have to tell you what the charge on ammonium is. It's always a +1 no matter what. And then I look up the next polyatomic, and it's a nitrate. So because I don't need the charges, I don't have to do any crossing or anything fancy. I just look them up, and I'm done. So that is some suggestions on naming ionic compounds. What if I have to write them from their names? So let's start at the top here. Potassium nitride. So potassium is a K, if I look that up. Nitride ends in IDE, which means it's an element. Nitri means, well, nitrogen. So there we go. KN, right? All done? Not quite. You have to check the charges to make sure you have the right number of each. So I look at my periodic table. Potassium is in the very first column, which means it's always a +1. Nitrogen is 3 away from the noble gases. So it's a -3. You might want to stop and check your periodic table right now just to take a look at where those are. So potassium is always a +1. Nitrogen is always a -3. So in order for this compound to balance, well, I need to have the same number of charges. If I have 1 +1 and 1 -3, well, that's not going to work. Those things don't cancel out. So this is where you can use the crossing method pretty easily. The -3 charge on nitrogen comes down here. The +1 charge on potassium goes down there. We don't have to write it. And that should work. I have 3 +1s to cancel a single -3. So that is the correct formula. You always have to write and cross down your charges. Let's check the next one. Aluminum, oxide, ALO. Not done yet because I have to check and cross down my charges. So aluminum, if I check my periodic table, it's always a +3. Oxygen, checking the periodic table, always a -2. So I cross them down. The 2 goes to the bottom of the aluminum. The 3 goes to the bottom of the oxygen. So the 2 goes down there. The 3 goes down there. And I'm done. That'll work. 2 sets of +3 cancels 3 sets of -2. Both of them will give you a charge of 6. The only time this crossing down doesn't work is if these numbers give you like a 2 and a 4, for example, or a 2 and a 2, then you reduce. So if it's reducible, you do have to reduce to the lowest number. Let's look at silver 1-phosphide. So I've got silver. I've got phosphide, ends in IDE, so it's an element. All right. Now, phosphorus, I know the charge on. Phosphorus is in the same group as nitrogen. It is always a -3. What about silver? Silver is a transition metal, so I don't know the charge on it, except for they gave me this Roman numeral, and that tells you the charge. So this is a +1 because it's a silver 1-phosphide. If it was a silver 2-phosphide, then my silver would have a +2 charge. That's what that Roman numeral tells you, right? It's the charge. So I can cross down now. I'm going to need 3 of my +1 silvers to cancel 1 -3 phosphide, sorry. All right, let's keep this train rolling here. Nickel 2 sulfide. So nickel with a 2 plus charge, matched with sulfide, ends in IDE, so it's a single element. The charge on sulfide is 2 minus. Across those, I get 2 and 2. Oh, 2 and 2 can be reduced, right? 2 and 2 are the same number, which means this is a 1-to-1 ratio. So I just write it as NiS. It is just nickel sulfide, just like that, because the 2's will cancel out. It takes 1 positive 2 charge to cancel 1 negative 2 charge. I don't need to have 2 plus 2's to cancel 2 negative 2's. That would be extra. And last one, manganese, Mn, not magnesium. Phosphate. Oh, here's interesting. We end in ATE. So if you have something that ends in ATE or ITE, that is not an element anymore. It's not going to be phosphorus. It's a polyatomic. So you're going to have to look that up on your polyatomic sheet, that yellow sheet, and figure out, okay, what's a phosphate? Turns out it's a PO4. And on that same sheet, it'll tell you that PO4s have a 3 minus charge. And manganese in this case has a 2 plus charge. All right, so we cross them down. I have 3 MNs. How do I write that I have 2 phosphates? Do I go like this? Well, that looks like PO42. That's not going to work. So what I do is I take the entire polyatomic ion and I wrap it in brackets. And I want to say I have 2 of these. I have 2 phosphates. So the 2 applies to everything. That means 2 phosphoruses and 8 oxygens in total. So I have 2 sets of phosphate. And I'd have 3 manganese. So 3 sets of plus 2 balance 2 sets of negative 3, because each phosphate's a minus 3 in total. So hopefully that cleared some stuff up. Again, if you ever have questions, right, you can always fire me an email or ask me a question or Google Hangouts or whatever you got, and we'll figure something out. Okay, covalent compounds. Way, way easier. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, etc. It's very, very rare that you get down into this range here. Hepta, no, hepta, that's a T. Sometimes it happens, but it's pretty rare. All right, so let's take a look. Naming a covalent compound. Now, like I said, these are way easier. You name the first one, and you put a number or a word in front that tells you how many you have. I've got 2, so it's not sulfur. It's disulfur. Di means 2. I guess I should write that out. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then how many oxygens do I have? I got 3. So it's tri-oxygen. Except I don't write oxygen. I always, no matter what I'm naming, changing the ending to IDE. So it's disulfur trioxide. The only time you do not use one of these prefixes here, mono, di, tri, etc., is if the first one is a 1. Just like this. Carbon, it's the first thing, and I only have 1 of them, so I don't write monocarbon. I'm allowed to just leave it off. It is the only time you don't write one. So this is monocarbon, dioxide. So it's just carbon dioxide. You leave the mono off. Carbon dioxide, easy. Next one. Mono, yes or no? Well, trick question. There's no mono on the first one because you never add mono onto the first one, but there is always a mono on the second one. So this is monoxide, which sounds ridiculous, so we just say monoxide. Nitrogen monoxide. And last one doesn't start with the 1, starts with the 2. So it's a di, phosphorus, 5, penta, chloride, always ends in IDE. There you go. Not too bad. And if you flip it over, try to do it the other way around, it's just as easy. I have phosphorus, chlorine, and there are 3 of them. I have nitrogen, and there are 2 of them. I have oxide, and there are tetra, 4 of them. So as long as you know the mono, di, tri, tetra, penta, you're pretty much good to go. Chlorine, fluorine, tetra. Chlorine with 4 fluorines. 5 carbons with 3 iodines. Carbon 5, iodine 3. C5I3. Pentacarbon triiodide. It doesn't matter how many times I say it. Triiodide never stops sounding crazy. But it is the correct way to say it. It's not triiodide, unfortunately. That would feel better, I think. Last one. 2 oxygens, 2 fluorines. All right. O2, F2. There we go. So the covalent ones, they're dreamy. They're the easy ones. They're the ones you want. Anytime you see mono, di, tri, penta, tetra, you know right away, covalent compound. I'm just going to write what I see. I don't have to worry about charges. I'm not crossing anything anywhere. I just write it how it's written. All right, we're going to balance a few now too. Get some practice on this. All right. Trick for balancing. You're always going to want to start, as often as possible, with the highest subscript. So that's the highest small number, which in this case is the Cl2. The only time you don't is if you have something that shows up a whole bunch. Like, okay, if I look at this one down at the bottom, we'll get here later. I see oxygen, oxygen, oxygen. There is no way I'm starting with oxygen. I will not be able to balance that because it's all over the equation. So even if oxygen had the highest number, which it actually does in this equation, it's a 3, I am not going to touch oxygen with a 10-foot pole. Not interested. So anyway, back to this one. Cl2, that's where I'm going to start. I got 2 chlorines on this side, which means I need 2 chlorines on the other side. So I write a big 2 in front. Now, as soon as I've got my 2 chlorines, I've also done 2 of something else. And so I'm just going to chase my tail, so to speak, going to chase this around until I'm done. 2 H's, all right, I need 2 H's. I already have 2, so I just put a 1 in front. And if I had one set of 2 chlorines, I also have 1 iron. Oh, 1 iron. There we go, I'm done. Everything should be balanced. So I want to double check. This side has 1 iron, 2 H's, 2 chlorines. Oh, that's not a 2. 2 chlorines. The other side has 1 iron, 2 chlorines, and 2 hydrogens. As long as these numbers are all the same, you have balanced it successfully. So good job. All you need is the 2. Oh, whoops. This was an answer key, so it's already got all the answers written on it. And that's not what I want. I want to figure them out. All right. So the next one, where to start? So I've got 3 hydrogens, 2 hydroxides, a PO4, 2 sets of PO4, or 3 calciums. So there's all kinds of places I could start here. And here's the thing, it doesn't really make a big difference, except I see oxygen, 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 oxygen. I don't want to deal with that. I have no interest in dealing with oxygen all over the place. So I'm going to start with, I don't know, let's do calcium. Why not? You could probably start with phosphate as well, would also be a good choice. Both will work nicely. Again, at the end of the day, it doesn't really matter which one you start with, but if you start with the highest one, you're less likely to get stuck and have to double something later. So if I got 3 calciums, I need 3 calciums. Now this makes 6 hydroxides, and if you look over here, I don't see hydroxide anywhere. So I'm going to stop there. I don't want to keep balancing with hydrogens and oxygens because I see H's and O's all over this equation, and I don't want to deal with that. So let's go back to where I started. If I say there's one of these, and I put my 3 calciums, well, I'm also going to need to look at my phosphates now. I have 2 PO4s. Balancing trick number 3 here. If you have a polyatomic like PO4 that travels together, treat it like it's a single atom. So I have 2 PO4s. I would need 2 PO4s. So that balances not only my phosphorus, it also balances those oxygens for me automatically. Now what's left? Well, I got hydrogens. So there's a lot of hydrogen all over the place, so I'm actually going to write this out so I can see it. I have 3 sets of 2 hydrogens. I have 6 H's here. I have 2 sets of 3. I have 6 H's here. So this side in total is 12 hydrogens. I have 0 hydrogens here, which means I need 12 on this side. How do I get 12? I'd make 6 sets of 2. All right, that's pretty good. Now, to make sure I actually did it right, there's one thing left to check, and that's to make sure the one thing I haven't looked at yet balances. I need to check my oxygens. 3 sets of 2 gives me 6 oxygens. 2 sets of 4 give me 8 oxygens, which I know should be balanced over here because I balanced PO4 together. So if I had 2 sets of 4 here, I made 2 sets of 4 on the other side. So that's why it's nice to move your polyatomics together. They make the last balancing easier. Anyway, 6 oxygens, 8 oxygens. Oh, how many do I have here? I got 6 sets of 1, 6 oxygens. So this side's got 6 and 8 is 14. 6 and 8 is 14. I'm balanced. You can double check if you want, but I've got 3 calciums, 3 calciums. I've got 2 phosphoruses and 2 phosphoruses right there. Oop, almost lost my 2. I've got, and I just did my oxygens and my hydrogens, so I know those ones work. So it's a 3, 2, 1, 6. All right, number 3. Where do we start here? I've got 1 sulfate, couple hydrogens, 1 hydrogen, couple bromines, 1 bromine. I generally try to avoid hydrogen and oxygen just because they tend to be the hard ones. So I'm going to start here. I got 2 bromines. I need 2 bromines. That gives me 2 H's. So I'm assuming this is a 1. That's where I got the 2 bromines from. I got 2 H's, 2 H's. So this is good. 1 SO4, 1 sulfate. So I need 1 sulfate, which gives me 1 calcium. And look, I've already got 1 calcium. I'm done. That was nice and easy. It's nice when they work out that way. All right, I'll just erase these numbers so you can see the answer key one underneath. Yep, got it. And here we go. This ought to be an interesting one. NaHCO3. So I've got bicarbonate here is the name of that ion. And I've got carbonate here. Not bicarbonates. They're not traveling together. So I'm going to have to treat the H's and the O's separately. Whoops. Cover that up. There we go. All right. So where do we want to start? Again, I don't want to start with O's. Probably don't want to start with H's. I mean, I could probably do H's here, but I'm going to start here with my sodium. So I'm going to pretend I've got one of these. That means I need 2 sodiums. All right. That gives me, well, if I want to do carbons, I'm in trouble because I've also got carbon here and carbon there. So I got carbon all over the place. So I don't want to look at carbon quite yet. What else only shows up in one other spot? It's actually H's this time. So I have 2 H's here, which means I need 2 H's here. So this has to be a 1 if I'm going to stay balanced. All right, I guess we'll check our carbons. I have 2 carbons here. And I already have 1 carbon here. So, and this, remember, this is my arrow right here, which means I need 1 more carbon. So I've already used up 1, which means this has to be 1 carbon to work. And if I'm going to double check and see if I got everything right now, I'm going to check my oxygens. 2 sets of 3, 6 oxygens, gives me 3 oxygens, 1 oxygen, 2 oxygens. 1, 2, 3, 4, 5, 6. Look at that. It balanced out. All right. Not too shabby. Let's do a few more here just to see the flow of things. Oh, this will be a fun one. So looking at this right away, this is what my eye's drawn to. I got 3 irons and I got 2 phosphates. I got all kinds of subscripts there I can work with. This will be a good starting point. Let's give that a shot. So 3 irons. I need 3 irons. Now, because all these elements are fairly different, I can just play that chase my tail game. 3 sets of 2 chlorines. That's 3 times 2 is 6. That gives me 6 sodiums, which means I need 6 sodiums. Gives me 2 phosphates. And hey, look, I already had 2 phosphates. I should be balanced. So if you want to count the atoms just to make sure, go for it. But if you've chased your tail correctly, it should work out really nice. What should we? Let's take a look at what happens if you don't chase your tail. Let's say I don't start with the highest subscript. Let's start here. Sodium. So I've got 1 sodium. Whoop. I've got 1 sodium, which means I need 1 sodium here. That gives me 1, whatever SB is, tellurium, tin. I don't remember. But I need 2 of them on this side. Oh, all right. Well, I'll make this a 1 then, which makes this a 2. So I got to double that one. Oh, but now I've doubled sodium, so I got to go back and double this one now. All right. This is fine. It's still going to work out. It's just you have to go back and revise some of your stuff. So now I've doubled my OH. How many oxygens are on this side? And oxygens all over the place. Maybe I'll balance my waters instead, because I see H only shows up here and here. So I'm going to save oxygen for last. 2 H's right here. So I need 2 H's. Look at that. So according to this, my oxygens should hopefully balance. I got 3 oxygens and 2 oxygens, gives me 5. I've got 4 oxygens and 1 oxygen. Hey, look at that. It works. That was convenient. But see, what happened was I got here and realized that, oh, I've got to go back now and double this one. And if I double that, I got to go back and double this one again. So if you don't start at the highest subscript, you'll often find that you have to double back. That's not to say that starting with the highest subscript always works. You will sometimes start at the highest one and still have to double. But starting at the highest one avoids it more often than not. All right. Now, right away, my eye goes here to that O10, but oxygen's all over the place. I don't want to start with the oxygen. So maybe I'll start with the phosphorus. So I've got, let's assume 1. I've got 4 phosphoruses. The only other place I see phosphorus is here, so I would need 4 of them. That gives me 4 times 3, 12 sodiums. Ooh. So I need 6 sets of 2. Now I got to check my oxygen. I've got 6 oxygens. This gives me 10 oxygens. 4 times 4 is 16 oxygens. Look at that. 6 plus 10, 16. It works. And the last one, I added this one in because it looks real complicated, but it's actually not too bad if you avoid the ones that show up everywhere. So I see H's here, here, and here. I see O's here, here, and here. So I want nothing to do with H's or O's for as long as I can avoid it. I'm going to want to balance other things. What else do I have? I got C's and I've got N's. My C's are already balanced, so that's nice. So I'm not going to bother with those. Let's look at the N's. I have 3 N's. Now, this isn't nitrates. This is an NO2, so I can't treat it the same as I treat this. I can't treat it as a polyatomic. I'm going to have to separate it. So I have 3 sets of nitrogen right now, which means I need 3 sets of nitrogen. And we just said my carbons are balanced, so if we're assuming 1 and 1, now I've got to figure out either my H's or my O's. And it shouldn't matter which one you do. You should still be able to get the same answer. Let's do, I don't know. Which one looks like it's less math? H's maybe? H's look like a little less math. I got 9 H's for this one. I've got 3 H's on this one. Oh, I won't even write the H. Let's just say 3. 3 H's. We know we're talking H's. All right. This gives me, so 9 plus 3, 12 is the number I'm looking for. And I've already used 6 H's here. Oh, not writing H's. I've used 6 already. So how many do I need there if I want a total 12? 6 plus, well, this should be 6. In order to get 6, I need 3 sets. Now, I haven't checked oxygen yet, and I have all my numbers in, which means oxygen better work. 3 sets of 3 is 9. 3 sets of 2 is 6. And 3 more. 3 plus 6 is 9. Look at that. It worked for us. So, balancing tricks. Start with the highest coefficient. Try to avoid, usually it's oxygen and hydrogen, but anything that shows up repeatedly in the same equation. And if you get stuck, just go back and double whatever you're stuck on and see if you can go from there. And that wraps up our review video. So hopefully that covers everything, gives you kind of an example of my method and stuff like that, and gives you some pointers. And if you have any questions, fire me an email.